Hello, my name is Aran Ali Lutfi, and this is my poster presentation for my final year project. So the research problem that I'm working on is that in Malaysia, monsoon flooding and flash floods occur almost annually, and Malaysia is in high risk of flooding, and there is no cost-effective and efficient IoT-based flood detection and avoidance systems, which is using machine learning. Therefore, the aim of this project is to design and develop an early flood detection and avoidance system using IoT and machine learning. My aims and objectives are as follows. One is to design a system that can detect temperature, water level, humidity in real time based on Arduino. Two is to develop an IoT system using LoRa that can collect and store data of current floods and previous floods on a server. Thirdly and lastly is to evaluate the proposed IoT system based on the machine learning and the accuracy of the flood data collected. Here we see the flow of my system. There are three sensors connected to my Arduino, and they give data in temperature, humidity, water level, and the rain sensor level. Here we see an Arduino Uno connected to a LoRa 915 megahertz shield. It's sending the sensor data through LoRa to a TTGO board. The TTGO board will relay the sensor data through MQTT to an upsquare. In the upsquare, we run the machine learning algorithm ARIMA in order to predict if there will be a flash flood or not. This data will be then uploaded into a Postgres SQL database and into a dashboard which is running on Node-RED. So what is the justification for ARIMA? First of all, at the beginning of the phase one, there was no database which we could work on. But after getting a comprehensive data set which gives the water and rain level at the river basins in real time every 5 minutes, it was possible to move from a fuzzy classification model to an ARIMA model. Secondly, ARIMA is not range sensitive, so it was possible for us to combine the data with the range of the sensor which we are using. With ARIMA, it was also possible to write it on Python, and it was compatible with Ubuntu, which was what the upsquare is running on. Therefore, it was possible to integrate all of the systems with ARIMA. Since we are not taking into consideration seasonality, it was not required for us to use ARIMA, and ARIMA will be faster for this instance as we are just predicting the next 10 minutes and predicting whether or not there will be a flood. So this is Node-RED. Here we are selecting the MQTT server, which is running on our upsquare. Once it is connected to the MQTT server, it will show connected, and then we'll select deploy. So now we can see that everything is connected, the temperature sensor, humidity sensor, the rainfall sensor, and the water level sensor. So once it's running, it will show the MQTT dashboard. The current threshold, which will be the AI prediction, will be printed here. And from here, we can select the sensor station, which is where the sensor system has been deployed. So which river, based on which river basin it's been deployed into. For example, it could be in Sungai Duyung, which is where our current system is. Here we can see the thresholds, which has been previously mentioned, the danger level, the warning level, the alert level. And if it doesn't amount to any of these levels, then it will show normal.